All right, so okay, we are going to look at graphing square root functions, and we're going to have it closely related to transformations, like the ones we did with parabolas, right? Moving it left, right, up, down, flipping it upside down. So let's start with making a table of values. Okay, so what we want to think about is what numbers would be good to plug in for a square root. So we'll start with 0. 0 is a good one. Because what's the square root of 0? 0. Okay.
4.
Let's plug in 1 and then we'll plug in 4 because square root of 1 is 1 and the square root of 4 is 2. Why don't we plug in 2 or 3? Because we would have a decimal approximation and we want to be able to graph these without a calculator. Okay? So let's start 0 0 1 0 or sorry 1 1 and 4 2. Am I going to have anything to the left of the y-axis? No. Look at the domain. Domain, x has to be greater than 0. Am I going to have anything below the x-axis? No. So the range is y is greater than or equal to 0. So here, kind of looks like a half of a sideways parabola, which it actually is half of a sideways parabola. So you want to try to make it a little bit curved. Good? Easy? Okay, so let's look at the rules for transformations of the parent graph. What happens when we add something under the radical? Is it going to move it up, down, left, right, a reflection? What do you think? What happens? Remember when we did... Remember when we had...
Left or right?
I'm going to write it. This is our square. This is our square or our parabola vertex form. So if it's x minus h, what does h do? It moves it left or right. If it's an x plus h, it would go left h units. Again, our goal here is to not do a whole bunch of table of values and spend our time doing that. We want to look at the transformations and be able to sketch these really quickly and accurately. So x minus h under the radical, we'll move it. Right? Good. Just like parabolas, just like the square root functions. Okay, now, what if we're just adding k to the outside?
Is it up k units?
It's up, good, up k units. So when it's under the radical, it's the opposite, right? If it's plus, it moves it to the left. Minus, it moves it to the right. But when it's outside the radical, it basically matches the sign. So minus k would be down. Okay.
There'll be a negative.
Okay, so it's going to be a reflection in the x-axis. It moves it upside down. Reflection. Okay, next one we haven't really encountered yet, but we're going to have it in many more functions. And this is what happens if the negative is under the radical. What do you think would happen? It's very similar to this one, but instead of a reflection in the x-axis, it's a reflection in the y-axis, meaning it would go like this, right? So this will be reflection in the y-axis.
Would that be an imaginary number?
No, okay, so just think about if it's a negative under the radical, all you can plug in are negative values of x. So you know what I mean by that?
No.
Like, if I had a table of values, and y would be square root of negative x, I could plug in 0 and I'd still get 0. But I can't plug in 1 because that would give me an imaginary number. But what happens if I plug in negative 1?
Oh.
I would get positive 1. What if I would plug in negative 4? Positive 2, because it would be negative, negative. So I can only plug in negative values and 0 if there's a negative under the radical. Okay, because we want to have like the double negative. All right. Okay, next one. What do you think? What happens if A is greater than A is greater than 1 and it's in front. That's a vertical stretch. Remember, like if there was a 2?
Yeah, you go up to.
Yeah, if there was a 2 in front, it makes it more narrow, right? Think stretching upwards, so vertical stretch. And what happens when it's less than 1, like a half?
Vertical compression.
Good. What?
Mr. Khan didn't even teach me that. Your daughter did.
Yeah.
The vertical stretch and the vertical compression?
Yeah, I had to ask her about it because I didn't know it.
Got it. Okay. Now, this is a new one. What happens, do you think, if underneath the square root,
The negative horizontal compression.
okay, we're going to have a horizontal compression or horizontal stretch. What do you think? Let's think of like a couple of numbers real quickly. Here, I'll give you an example.
0.
Take 2 different examples.
I think it should be a stretch.
Take y equals square root of 4x compared to
The negative compression.
square root of 1/4 x.
We have.
So if I plug in 0, I get 0. If I plug in 1,
You get 2.
I get
2.
2. If I plug in 4,
You get 4.
4. So what happens to the numbers? Are they
Up
getting,
by 2.
they're getting bigger? Okay. So, and then what about 1/4? So we get 0. If we plug in 1, we get a half, because square root of 1/4. If I plug in 4, I get 1. So which one? So when b is greater than 1, a horizontal,
Stretch.
it's actually backwards. Because the y values are bigger, but the x values are smaller. So this is going to be horizontal compression. And then,
Are we gonna see what that looks like?
yeah, we'll see what it looks like. You know, it's actually easier when we get to trigonometry. You'll see it much more. Yeah. Because then you actually see a pattern with like the sine curve. Looks like a wave. And you'll see what it looks like when there's a horizontal compression.
I'm guessing that's when it's horizontal stretch.
Okay, domain, set the radicand. When I say radicand, do you know what that means? It's the part under the square root, okay? And solve for x. That will automatically give us our domain every single time. The range, so if a is greater than 0, right, like this one, a was positive 1, so it's going to be y is greater than or equal to k. Remember, k is how much we move it up or down. And if it's less than 0, it's going to be y less than or equal to k. That's the same rules for parabolas. Same exact rules, whether we remember that or not. We'll see. Good? Okay, so now we're going to graph them. Let's see. And we're going to identify the domain and range. Okay, square root of x minus 2. It's going to go to the right 2. Again, our goal is to not have to, we don't want to have to do a table of values every single time. So our parent function was just the square root of x, right? So when we plugged in 1, we got 1. When we plugged in 4, we got 2. Here, I would go over 1, up 1. And we could go over 4, up 2. Or you can think of, you could just think of also, what could you plug in for x? I could plug in 6, right? 6 minus 2 would give us square root of 4. And that's our curve.
Why would you go up
You need a minimum of 3.
Oh, because you're just.
I'm relating it to the parent function. So the parent function was square root of x. So if you look at the here, from our starting point, we went up 1 over 1, and then we also went up over 4, up 2. Now, we can only do that when the coefficient is 1 in front of x.
But if you plug in 0, 0 minus 2 is -2.
Yeah, we don't want to plug in 0, though, because let's think of our domain. What's our domain? We want to set the radicand, the part under the radical, greater than or equal to 0, because we can't have negative values. So what happens when I solve here? I get x is greater than or equal to 0 for the domain. How about the,
Zero.
or, sorry, 2. And now our range,
We haven't. You can put it under. Like there's the lines for.
so are we adding anything? Is it being moved up or down? No? So it's going to be y greater than or equal to 0.
If there are lines to put the domain and range on the function. Under the graph.
Oh, thank you. I did that. I didn't even remember I did that. That's better. Okay. More space there. Okay, next one. Where are we going to start? So this is going to go to the right,
And then up 3.
right 4, up 3. So go to the right 4, up 3. This one, is there any kind of vertical stretch or horizontal? No. So I could go up 1 to the right 1. And then I could also go
Down 4.
over 4, up 2. If you're not sure, you can just think again, what can I plug in for x that would make this a perfect square? Oh, I could plug in 8, right? So if I plug in 8, 8 minus 4 would be 4, square root of 4, 2, 2 plus 3, 5. So I know 8, 5. And I put it at 4, 3. That's where we start. Okay, so again, I'm trying to get that translation over 4, up 3, and then we'll sketch the
Or
graph.
you can just always use up 1, up 1.
Yeah, except for C, notice there's a 3 in front now.
Okay, yeah.
So we'll see how that changes.
There's like 3.
Yep. What's the domain?
X
X is greater than or equal to 4, because remember, we're going to take x minus 4, set that greater than or equal to 0, so that's how we get that. How about the range? Is it greater than or less than? Greater, because it's going up. How many units did we move it up? 3. Remember, it's always the value of k. Good? Because it was moved up 3. Look at our y. Look at when we graphed it. We started at 3 and it went up.
So why is that one 0?
Which one's 0?
The A.
It started at 0. There's a y value of 0. There's nothing added to. Okay, next one. Where are we going to start?
You're going to go right 5.
To the right,
And then it's a stretch of
5. So it's going to go 5, 0, right? There's nothing being added.
3 over 1.
Yeah, so think about that. If I plug in,
That's going to be
if I plug in 6, 6 minus 5 would be 1. So 3 times, so if I go over 1, I'm going to go up
3.
3 this time.
And 3 to 11 too. Oh.
If I plug in 9,
Yeah.
you get, so again, if you're not sure, just remember you can do a little table on the side for just a couple values if that's easy, Why did I choose 9 to plug in? Because then it would be 3 times square root of 4, which would give us 6. So we could go 9,
How would that give us six?
because root 4 is 2. 3 times 2 gives us.
Oh, six.
Right. Okay, our domain, we set x minus 5 greater than or equal to 0, which gives us x greater than or equal to 5. And the range,
Has to be greater than 0.
good.
Is it always like equal also?
Always equal.
Actually, you don't want us to make a graph? Like a table graph?
No, unless you really want to.
Shouldn't do it.
If you're not sure, generally speaking, I'm going to ask for like 2 or 3 points.
2.
2. You like 2?
I like to.
Okay. 2 points are fine. Because the graphs are always going to look the same. As long as you can figure out, even if you did this second point here, you can already see it's a vertical stretch, right? Okay, how about the next one? Where are we going to go? We're going to go left 4,
Up 6.
No, down.
down 6,
Oh, down.
right? So -4, -6. Put a point. That's like our starting point. But it's a negative. So it's going to go down 1 to the right 1. And it's going to look like that. Okay.
There's no third point.
Oh, you want to do a third point? We can do a third point. Here. If I would want to plug in, what would be a good number to plug in?
4. No.
How about 0?
Yeah, 0.
If I plug in 0, that will give me 4. So
2 minus
-2 minus 6 would be -8. So there's a third point if you want it. Okay, my domain is going to be greater than or equal to -4. Good. Domain. Because the negative, instead of greater than or equal to, it's going down, so it's going to be less than or equal to, what was my value of k?
6.
N-
Negative 6.
-6. Okay, we're getting the hang of it.
Are we gonna have to graph on our homework?
Okay, so it's whatever.
Yes.
Outside number.
I have little
They graph stick.
little post-it graphs I can give you, or I can print out graph stuff, papers.
Can you give us one?
So your range is whatever's on the outside? Like here? That's
Yeah,
gonna be your
mhm.
range?
Okay.
And then domain is whatever's on the inside?
Yeah. Okay, when they get, this one gets a little more complicated because what's the radicand? 2x plus 1. Okay, let's look at the domain first because that's going to give us our starting point. So I'm going to have 2x greater than or equal to -1. So x is greater than or equal to -1/2. Okay, so that means -1/2, and notice there's +0 at the end, there's nothing, so it's just going to start at -1/2, -0.5 right here. The range, okay, be careful here, there's a negative in front. This one, I would maybe recommend a little table of values if we're not sure what this looks like.
It's gonna go down 1 to 1.
Yeah, so this is a little more complicated because it has a 2 underneath. We can only plug in values greater than or equal to 1/2. What would be an easy value to plug in?
2. 4.
No.
2.
0?
Oh, 0.
Oh.
0 is always 0.
Okay, plug in 0. What happens? That just becomes square root of 1, which is 1, but there's a negative out in front, so it's -1.
0 negative 1.
Okay, 0, -1.
Oh, because it's negative square root of
Okay.
one, which- oh.
Can you think of another number?
8.
How about 4? You'll see why.
Oh yeah, because 9.
I'm trying to figure out what numbers would give me a perfect square. So if I plug in 4, 2 times 4 gives us 8. 9, square root of 9,
Negative 3.
so negative 3.
Negative 1/2. Oh. It's 0.5. 0, 1, 0, negative 1.
Okay, so it goes like this. Whoops. And what do we have for the range? Less than or equal to. Good. So it's a lot harder when the coefficient is under the radical, right? So when it's outside the radical, it's easier because you can just right? It's a lot easier to substitute in. And when you don't have any coefficients, those are the easiest. Okay, what's the next one?
Sorry, why'd you choose 0?
I chose 0 and 4 because that would give me a perfect square. If I plugged in 2, that would give me 4 plus 1, which is 5. I'm not saying you can't do it, but the goal is that you want to be able to do these without a calculator, right? So you're trying to pick numbers that would make it perfect square. Okay, this one we could probably do without a table. Where do we go? Left 4, down 6. And everything's positive and the coefficient is 1, so we could go up 1 to the right 1, and also go to the right 4 and up 2. Again, if I plug in 0, I get 2. 2 minus 6 is negative 4. Again, 2 points will get you a good view of the graph. Let's see. So this is going to be x is greater than or equal to negative 4, and y is greater than or equal to. Oh, I did not mean to. That's not supposed to. The honors class does inequalities with these, but we don't really need to do that. You don't need it. So this is like an example where like your packet will be a little bit different. I'll have it like crossed off like that stuff. Yeah. Honors, they do more like word problems and more like, yeah. Word problem, we call them applications. I mean, that's really the distinction between honors and regular throughout high school math. They just do more of. Okay, so, I didn't leave a space for domain and range here. Yeah, it's positive 1/2. And that's going to go right here. Okay, this one's similar to the one right above it. Can you think of? Then it would give us negative 1. 1? What happens when I plug in 1?
0.
Wait, 2 times 1 is 2. 2 minus 1?
1.
Square root of 1? 1. So 1, 1. Can you think of another number that would give us a perfect square? 5. Because 2, you can almost just like try different numbers. Like if I plug in 2, that's not going to work. That's going to give me 3, right? Just keep thinking of numbers until you get a perfect square. So yeah, we get 3. So 5, 3. And last one. I didn't ask domain and range, but if I did, domain would be greater than or equal to 1/2. Range would be y greater than or equal to 0. Good.
I have a question.
Yeah.
So I thought like because the h is like negative 1, so does that mean that would move to the right one?
But wait. No. This one has a coefficient. So when there's a 2, we have to set this greater than or equal to 0 to figure out our starting point. Okay, last one. Negative 2, negative 4. And this one's going to go here. And wait, if I plug in 3, No. But if I plug in 3, that's going to give me square root of 5. How about plug in 2?
Oh, yeah.
If I plug in 2,
You look at it too.
when I get negative 6,
Then get a negative 2.
how do I get negative?
What is that?
You get negative 2.
Oh, wait. Actually, no.
1 and
Yeah, what is that?
Negative 1, negative 5.
This is negative 2, negative 4. And since there's no coefficients, but there's a negative, I go down 1 over 1.
Wait, then how'd you get the next thing?
Okay, so if I plug in 2,
You get 0.
no, because square root of 4 would be
Oh,
2. Negative 2 minus 4.
negative 6.
Again, if it's too much to try to do it all in your head, just make a little table on the side. Okay, on your calculators.
Wait, what is the domain?
Oh, yes. What is the domain? Domain would be x is greater than or equal to negative 2, and the range would have to be less than or equal to negative 4. Now, we can graph these on our calculator to check, right? So we would have negative, so like if I want to check this last one, square root of x plus 2, and then you just have to use the arrow to go outside this. Right. So we can check easily with the calculator. Of course, that probably means that you won't have access to this calculator for graphing on the test. If it kind of does everything for you.
It's got a